Okay, so the neuron starts at its resting potential and then later gets hit with a stimulus that pretty much charges it past the threshold of -65 and shoots it all the way up to +30. So that way it is charged, that's depolarization. And then after the charge is passed, it hits its repolarization, drops all the way down to -80, and then has a little refractory period that kicks it back up. That's active transport because it takes energy to like continue pushing what charged it, which was the sodium that was allowed to enter and cause the depolarization. That's what gave it a charge, the sodium and the potassium. This is then, pushed along in the sodium potassium pump, along with that's how facilitated diffusion works, is it's just spreading it down, allowing the charge in a repeat of depolarization, repolarization, refractory. Depolarization, repolarization, refractory. Always going past the threshold and shooting it to the same charges roughly. So and then that also takes, energy, so that's active transport. And then this happens because of the concentration gradient with the sodium, which is when it opens, it wants to spread the sodium to more or less concentrated area from the more concentrated area. Because concentrating gradients, everything's trying to like balance itself. So more dense stuff wants to spread out, and then the less dense stuff wants to add that charge or that sodium.